Okay, our last review topic for this unit is going to be solving systems of equations using elimination. So for our first example, two equations, 5x minus 6y equals negative 32, and 3x plus 6y equals 48. So as to recall, for elimination, we have to have a pair of variables that have the same coefficient but opposite signs. And in this case, we do. It is also important that we line everything up, that our y's are lined up, our x's are lined up, and our constants are lined up. And once we have equal but opposite coefficients on one of the variables, we can take the two equations and we can add them together. And so when we add the first line to the second line, 5x plus 3x is 8x. The 6y's cancel. Negative 32 and a positive 48 give us a positive 16. We can solve this by dividing both sides by 8, and we're left with x is equal to 2. Again, we're only halfway done. Now we have to take that 2 and substitute it into one of the equations. Doesn't matter which one, okay? I think the bottom equation is nicer. Everything's positive. Most of you hate dealing with negative numbers. So I'm going to take that equation, 3x plus 6y equals 48, and we are going to plug the x equal to 2 into that equation. So we get 3 times 2 plus 6y equals 48, or 6 plus 6y equals 48. Subtract 6 over. 6y equals 42. And when we divide the 6, y equals 7. We now have both parts. Our solution, x first, then y, and we write it as a coordinate. Okay, let's see them get just a little bit harder. Number 2. If we have the equations 2y equals negative x plus 7 and 3x minus 2y equals negative 3, our y's look like they're going to work out. The problem is our x's aren't on the same side. So we've got to fix that. We've got to get it back into what we've called standard form. Normally when we do elimination problems, we always put in standard form. X term, y term equals constant. So when we go to do that, we're going to have to reorg the top one. We're going to have to take that 2y equals negative x plus 7, and we're going to have to add x to both sides. So when we rewrite this, we get x plus 2y equals 7. Okay? Got the x and the y on the left, the constant on the right. this equation was already in that form. 3x minus 2y equals negative 3. And now we see that our y's are equal but opposite, and they will cancel out. So when we add these two equations together, we get 4x equals 4. X plus 3x is 4x. 7 plus a negative 3 is a positive 4. Solve for x by dividing both sides by 4, and we get x equals 1. At this point, we can plug it into any of the equations up here. I'm going to pick this original first one. I'm going to bring down 2y equals negative x plus 7, and we're going to substitute in the 1 into that equation. So we get 2y equals a negative. Now we're putting in the 1 plus 7. Distribute that negative. 2y is equal to negative 1 plus 7. A negative 1 and a positive 7 give us a positive 6. Solve for y. Y equals 3. We got y equals 3, x equals 1. We can write that as a solution set, 1, 3. Again, our examples, as we continue, we're going to ramp them up, make them a little harder. So let's look at a third example. Negative 2x plus 15y equals 28, and 7x plus 5y equals 17. In this case, we don't have a variable with the same coefficient. Okay, 15 and 5 doesn't work, 2 and 7 doesn't work. But we can look for patterns. 15 and 5, we know 5 times 3 will give us 15. And we need them to have opposite signs, so we can take the second equation and multiply the whole thing by negative 3. That will give us a negative 15y, which is the opposite of the positive 15y. So the first equation I'm just going to rewrite. Negative 2x plus 15y equals 28. The second equation we have to distribute. Negative 3 times 7 is negative 21x. Negative 3 times 5 is a negative 15y. And a negative 3 times 17 is a negative 51. Now we can add those equations, and we see our y terms are going to cancel out. Negative 2x and negative 21x is negative 23x. And 28 plus a negative 51 is a negative 23. Divide through by negative 23. We're left with x equals 1. Now we have to finish it off. We have to substitute that in to one of the original equations. I like the second original equation better because, again, it's all positives, and I prefer positives. It's just easier math. So if I bring this equation down, 7x plus 5y equals 17, and we go and we substitute in x equals 1, we're going to get 7 times 1 plus 5y equals 17, or 7 plus 5y equals 17. Subtract the 7. 5y is equal to 10. And when we solve for y, we get y equals 2. Y equals 2, x equals 1. Our solution, 1, 2. Remember, x always before y. Okay, last example. Seven x minus 3y equals a negative 5, and 3x plus 2y equals 11. So in this case, neither pair of variables match again, so we're going to have to do some multiplying. Well, 7 and 3, they're going to have to be multiplied together and get a 21 for that to work. So we'd have to multiply this one by 3, that one by 7 to get 21s. This case, the 3 and the 2, we could cross multiply and get 6s. 3s and 2s or 3s and 7s, I think 3s and 2s are smaller numbers. So I'm going to pick the smaller numbers whenever I get the chance. Again, if you pick the other one, it's okay. It will still work. The numbers will just be a little bigger. So these are already opposite signs. That's nice as well. So 3 times 2 will give me a 6y, and the 2 times 3 will give me a positive 6y. They'll be opposite, and we'll be good to go. So 2 times 7x is 14x. 2 times a negative 3y is a negative 6y. And 2 times a negative 5 is negative 10. For the second equation, 3 times 3x is 9x. 3 times 2y is a positive 6y. And 3 times 11 is a positive 33. Again, the goal was to get a set of variables, could have been x, could have been y, equal but opposite coefficients. So that when we go through and we add them, 14 plus 9 is 23x. The y's cancel out. 33 and a negative 10 is a positive 23. We can divide both sides by 23 and we're left with x equals 1. Plug back in to one of the equations. Again, I'm going to pick the second one because I think these are nicer numbers. 3x plus 2y equals 11. And when I insert my 1 for x, I get 3 times 1 plus 2y equals 11, or 3 plus 2y equals 11. Subtract the 3. 2y equals 11 minus 3 is 8. And when we take the 2y and we divide through, we get y equals 4. Okay, so our answer here is going to be 1, 4. That concludes our review of substitution.